Hello, my name is Dominique. I'm a software engineer at Facebook, and I'm here to talk about reliability and the reliability program that we ramped up over the last 6 months by reusing our existing performance tools. There are, of course, some differences in the way we measure perf and reliability. I'm going to draw parallels between perf and reliability wherever possible and point out the places where we needed to adapt. I want to start off by clarifying our understanding of reliability. In this talk, I'm going to focus on what we call functional reliability, which we define as the ability of a system to deliver the outcome expected by the user. Examples are, did a comment post, did a photo or video load? And we're going to take a very user-centric look at this. As an example, when a user deletes a story and the transaction succeeds on the backend, but the UI doesn't reflect that, it's a failure. This is distinct from app reliability, which deals with app crashes, stalls, and app deaths. It's also distinct from server reliability, which is not directly user-facing, but can of course impact functional reliability. We're focusing on functional reliability, but I will circle back to app reliability and server reliability at the end. At the beginning of the year, we couldn't really answer the question of how reliable Facebook is. Well, at least there wasn't a single answer. There are four main factors that made this question difficult to answer. As you probably know, Facebook is made up of many different products, each with a rich set of features. There are almost endless things that can break. And these products are built by dozens of different teams inside of Facebook. Our engineers are very creative and autonomous. They come up with many different ways of measuring the reliability of their products, and this might work well for them. The problem is, this makes comparing the numbers across teams and products very difficult. Without a holistic view, you might think that everything is fine. Anecdotally, you might hear from people that things are burning, but you don't know where or what. Bug reports can help here, and we are receiving thousands of them every day. While this is a super valuable signal, especially with smaller products, it's still not enough to know what is broken. We found that 10,000 users need to hit the average problem before finding a bug. We do have very talented engineers that fix really hard bugs. However, with hundreds of engineers committing thousands of code changes every day, it's really difficult to protect those wins and to manage regressions. Luckily, we're not starting from a clean slate this time. Last year, Shrupa Biswas talked about the performance push that we started in 2018. This was part of her keynote speech at Performance at Scale, which is a community conference organized by Facebook, and I highly recommend to watch this talk. We applied the learnings from our perf push to our reliability program, which boils down to three guiding principles. I know that a lot of people here work in big companies. Tackling this from a central team of reliability experts to deal with all the issues is simply not scalable. Instead, we went for a federated, partnerships-based model. By setting the right incentives, we can harness the enthusiasm and domain knowledge of product teams and app foundation teams. Ultimately, those are the people that know the products the best. As we did for performance, we wanted to look at reliability through the eyes of a user. As a result, we're looking at the full end-to-end experience of the things that users care about and that just need to work. All the tools that I'm going to show you today were originally built for measuring and tracking performance. We have repurposed them with only minor adjustments to measure and track reliability. This gives us consistent measurement, tracking, monitoring, and debugging capabilities across the whole family of apps. It also gives us high-level scorecards, so we can see where we're underwater and better staff the biggest problems. I want to give you a high-level overview of the reliability program before diving into the details of each of these steps. We started off by identifying the things that users care about. Things like sharing a photo or deleting a comment. We call these core flows. We then add instrumentation to the code to capture and log those flows. Based on that, we define metrics and set goals on them. When we find that certain flows don't meet our goals and expectations, we would start an investigation to debug why. Lastly, all the metrics and goals for each flow are tracked at a central location and continuously monitored for regressions. We started off by mapping out the core product areas and then sourced the core flows from various product teams. Some of the flows are very simple, such as loading comments, but they are still very important. Others are more complicated, such as this one. In this case, it really helps to diagram out the various paths through the flow. Our guiding principle for instrumentation is that it should match the user's perception. A flow typically starts with a user action, such as a click or launching the app. At this point, we would put up a start marker and start a timer. At some point, we might receive content from the server and mark this point. Note that the flow is not complete yet. It still needs to render the new content and display it to the user. At this point, we will mark the end of the flow. We're using our open source tracing library, Profilo, to collect this data from production and send it to the server. At any point in the flow, there might occur an error. In this case, we would mark the flow as failed and attach some useful debugging information, such as the error message and the stack trace. For debugging, it's important to know where in the flow the error occurred. Was it before or after the response returned, during rendering, or somewhere else? Of course, at any point, there's also the chance that the user cancels the flow, navigates away, or closes the app. In this case, we would add a cancel marker. There are quite a few similarities between perf and reliability. In fact, some of the flows were already instrumented because people were looking at their performance and were using the exact same tools. The flows we instrument specifically for reliability tend to be more complicated, longer, and involve more than one user interaction. When we have our perf hat on, that's the one on the left with the tiny stopwatch on, we would be more interested in the duration of the flow. With the reliability hat on, that's the one on the right, which is more heavy duty and safe and reliable. We are looking more closely at the outcome of the flow. Was it successful? Was it cancelled? Or was there failure? With the instrumentation in place, we have tools to look at a single execution of the flow, as well as the data in aggregate. From this raw data, we somehow need to make sense of the numbers. For performance, this has historically been very difficult. There are many different choices here. Averages and variance, P50, P95, P99. We also learned from Alex Kellenbeck in one of the previous performance summits that performance is a shape, not a number. So we might want to be looking at histograms and distributions as well. What we settled with, at least in most cases, is what we call percent fast. It's defined as the number of samples for which the duration is lower than some predetermined threshold, such as 200 milliseconds, divided by all the samples. This is our real-time metric that gives us a very fast signal. Our research has shown that a single slow interaction can ruin the experience for the user. This is why we also look at a user-based metric that is aggregated daily. This is defined as the number of users for which all samples are below that threshold, divided by all users. For reliability, the choice is much more obvious. Our main metric is percent success. That's the number of samples for which the flow was successful, divided by the number of samples for which the flow was either successful or failed. We're ignoring cancellations for now as we need more research on how they affect the perceived reliability. We're looking at an additional metric, percent eventual success. This is to understand whether a user eventually reached their goal, perhaps by retrying, despite having a suboptimal experience. It helps us to understand whether a flow is completely broken or whether there are just some transient errors. Once a metric is defined, we can plot the values to get an initial understanding of how reliable the flow is. Next, we need to set goals on these metrics. For performance, we've been using this concept of interaction classes that were inspired by Microsoft's Planning for Performance article. These are based on the user's perception of speed. Some interactions need to be fast, such as the response of a button click. For other interactions, a 1-second delay is still acceptable. Similarly, for reliability, we introduced reliability classes. R0 is defined as 99.999, also called 5 nines reliable. We use this for things like deleting content or changing privacy settings. R1 is typically used for creating content, such as writing a post or writing a comment. R2 is used for viewing content. Looking back at the metric chart, you find the dashed blue goal line at the top. Interestingly, the goal value is rounded up to 100, which I think is a bug. Anyhow, you can clearly see that the metric is below the goal. To understand why, I'm going to talk about the debugging capabilities that our tools provide. For performance, we would look at the breakdown of subspans within the flow to understand where time is spent. This can also be useful for reliability if an excessive amount of time is spent at some place and that would lead to a failure. In most cases, it's more useful to look at the Sankey diagram. This helps us to understand at which step of the flow the user drops out. In this case, we can focus our investigation on the delete mutation end, as this is the only path that leads to a failure. A different approach is to look at server-side errors that were correlated with the flow. We do this by annotating each network request from the client with an identifier for the flow that is currently active. When on the server side we throw an error, it will be logged with that flow identifier, and this allows us to correlate flows with server-side errors. We can look at the details of those errors to see how many users it has affected and to find stack traces. In this case, the user has entered an invalid email address. This can indicate an instrumentation error or an actual bug. Finally, we roll up all the metrics in a centralized tool. This allows us to get a holistic view on the reliability of the overall system. In this chart, we can see how many of our metrics are at goal. If we see a sudden dip here, this can indicate a site-wide issue, and we can start our investigation on the infra side rather than the product code. In the same tool, we also have high-level scorecards, so we can see what's burning and better staff the biggest problems. This is also the place where our detection systems hook into. Here, it flagged an issue with data unavailability. And here's one for which a regression was recently detected. These automatic detection systems help to protect our wins and make regression management scalable. Zooming back out, I want to point out the fluid and iterative nature of the program. As we add instrumentation, investigate issues, we constantly identify new flows, improve our instrumentation to cover all the possible outcomes, and refine our metrics. In reality, the process is not a waterfall as shown here, but perhaps something that looks more like this. We started this program 6 months ago, and there's still a lot of work ahead of us. Here's a brief outlook to the things that are coming next. We're going to consolidate functional reliability with app reliability. We're going to annotate crash reports with the flows that were active at the time of the crash to allow correlation between flows and crashes. We are going to look into cancellations. A user leaving the flow can be a deliberate decision, but it can also mean the user experience is just completely broken. Think about a case where the user fills out the form, but there's just no submit button. Our flows are becoming ever more complicated and can now span across apps. We're working on improving our instrumentation tools to account for that. This program has focused so far mostly on the things that absolutely need to work. Beyond that, we're going to invest more into user research to understand what users really care about the most. Lastly, we're working on tools to better understand the coverage of our program and to identify where we have gaps. To wrap up, I want to talk about the two things that I hope you take away from this. First, focus on the user's experience. How long did it take? Did they reach their goal? If not, how far did they get and what was the error? Because we applied this principle when we built out our perf program, most of the tools and workflows were already in place for our reliability program. It's just a different set of metrics derived from the measurements of the user experience. Second, tracking metrics at a central location has many benefits. It helps to understand the overall health of the system and to detect trends. It also allows us to identify the areas that need more attention. All right. I'm looking forward to answer your questions that are coming in via Slack.
Thank you so much for this amazing presentation. I think like it's pretty clear that reliability is pretty much yet another aspect of performance, just because when you look at especially distributed systems, the system that is not responsive at all or just slow is pretty much indistinguishable from performance reliability perspective. So it's great to see that the same infrastructure that powers performance monitoring and instrumentation can also power reliability aspects, which is great. While we are waiting for questions to pop up, I was wondering about the what do you like? What is the how do you deal with the fact that there could be low volume crashes happening? They can be very important, very disruptive, but low volume just because, for example, they are for uncommon scenarios or just tricky cases which are non-reproducible, like for example when they happen due to some Heisenbergs or whatever. How do you deal with those? Like, how do you communicate the impact of these crashes to developers and make sure that people actually act on them?
Right. Thanks for that question. So for now, we're actually not correlating crash reports with reliability metrics, but what is something that is very similar is server-side exceptions that can also indicate such an issue. And what we're doing there is, right now, we're just looking at what are the exceptions that can be associated with a particular flow, or the other way around. For a particular flow, what are the exceptions that have happened? We are planning to do a more sophisticated statistical analysis to see what are the exceptions that are unique to a flow that only happen to that flow, and that could also flag very low volume exceptions. And once we have that correlation with crashes, that would work in the same way. Does that answer your question?
Yeah, absolutely. And I'm also wondering about the I guess the early feedback. You mentioned that you started implementing this program fairly recently, so I'm just curious, like what is the reaction of developers that start getting this information? Do they find it easy to use, useful? Like basically, how did their experience? How was their experience affected by these changes?
Right. I'm not gonna lie. We have faced some pushback from engineers and also some managers. But what helped a lot was that our performance push has been very successful, and that we could show in the very early stages of this program also some wins. And I think the key actually is setting the right incentives, and that can come in two different aspects. One is on the technical side. So if you use our tools, you get certain things for free. So things like regression detection is something that you would just get if you use our tools and if you instrument your flows, which has historically been something that people would have implemented themselves. And the other thing is recognition by our leaderships. So this program, like we got sign off from our leadership, and it's generally understood that if you prove reliability for a flow, then this is impactful work. Or if you push certain flows over a goal, this is really impactful work, especially since you can compare the different numbers across the different product areas.
Awesome, that sounds great. I mean, it's such a groundbreaking work that it's, I guess, somewhat expected to have a little bit of pushback, but I think as people appreciate the value that this infrastructure provides, I think I'm pretty sure their opinion is going to change. And also, just in general, it's probably not always obvious whether you want to invest in something new before its value is proven. So I'm pretty sure you'll soon have success, complete success to report. And yeah, I'm looking forward to hear more about your experience. So let me double check if there are, okay, so there are no more questions. And since we're a little bit behind the schedule, I'm gonna let you go, Dominique. Thank you so much again for joining us and talking about the reliability. I hope we are gonna, in future, we are gonna start covering even more reliability topics, and because I think they are extremely important for everyone. performance, same as reliability, has a huge impact on the overall user experience. And user experience is what we work for. We strive to deliver the best user experience, holistic experience, and it doesn't really matter if it's slow, it's crashing, it's bad user experience. So we just, I think, hopefully collaboratively, we'll be able to address these challenges and have all of our customers super happy. So yeah, thank you so much, Dominique. As for everyone else,
I agree with you, and it's been a pleasure.
Thank you. So we're gonna have a panel discussion starting in 2 minutes. We have a small change in the panelist list. So Eiko is gonna replace Dominique, and unfortunately also Alexander, who's based in the US currently, won't be able. Like I felt too bad for ruining his night, so I asked him to not participate and just enjoy his sleep. So I hope to see everyone in 1 minute for a panel discussion. Don't forget to start asking your questions on the channel, and I'm looking forward for the opportunity to chat about performance with such an amazing panel.